Hello everyone, I am Yashraj Rati from IIM Mumbai and today I am going to teach basics of trigonometry. Just a disclaimer, please ignore my background as I am in a hostel room and please ignore any unnecessary sounds which would come from my mic as well. So what is trigonometry? So trigonometry, is it something that you fear or is it a topic that you all want to skip? Or is it something that you think has no real life application? And when you hear the word trigonometry, do you feel like, "Aye, but what actually is trigonometry?" Let us consider a right angle triangle and let us consider this angle as theta. I know this doesn't look like theta, but please bear with me. This is the opposite side to the angle theta, this is the adjacent side, and this is the hypotenuse. You all know what is hypotenuse. It is when we have all studied Pythagoras theorem in schools. So let us look at three main heroes of trigonometry. The first is sine, the second is cos, and the third is tan. I know you guys get a lot of confusion between all these three, that's why this meme. And we can say that these three are the heroines of the respective heroes, but more on this later. So I'll tell you a basic mantra of trigonometry which will help you solve all the basic questions and to have trigonometry basic knowledge lifelong through this mantra. So this mantra go goes as so ka toa. Just remember it. So ka toa. So what is so ka toa? For example, let's take sine theta. So this is this is the angle theta, and so is sine, O is the opposite side, and H is the hypotenuse. That is so. Now let's look at ka. C is cos, A is the adjacent side, and H is the hypotenuse. And toa, as you all have guessed until now, this is opposite by adjacent, and T is tan. So the mantra for trigonometry is so ka toa, and your life will be set. So as we were talking about some heroines, so sine theta is equal to 1 upon cosec theta. That means the inverse of sine theta is cosec theta. The inverse of cos theta is sec theta, and the inverse of tan theta is cot theta. When you look at tan theta is also sine theta divided by cos theta. And as we know, the inverse is cot theta, so cot theta would be obviously cos theta by sine theta. Now let's look at some universal triangles in trigonometry that will help you solve many problems, many basic problems which are required to apply trigonometry in real life as well and to solve many problems, be it CAT level, be it CET level or anything. So let's consider a 90-degree triangle. This is an isosceles triangle with both angles at 45 degrees. And let's consider another triangle. This is called a 30, 60, 90 triangle. So for this, these sides are in the ratio of 1 is to 1. No matter what is the length, the ratio would always be the same. As we all know, isosceles triangle have two equal sides. And due to Pythagoras theorem, this side, the hypotenuse would be square root 2. And in 30, 60, 90 triangle, the ratio would be the side opposite to the 60 degree. As 60 is the larger angle, it's a trick to remember. So 60 is a larger angle. So this side is square root of 3 and opposite of 30 is 1. And when we apply Pythagoras theorem, this side becomes 2. Now, if you remember these two triangles, you can create a table which can help you solve many trigonometry problems. And this I consider to be a base of trigonometry. I haven't read any fancy books or such to teach, but whatever I have been taught from my 10th grade to the engineering maths of whatever my background is, this is, I believe, the base of trigonometry. So, for example, let's see this table. This is the table which I believe everyone should be able to derive from these two triangles. So for example, let's consider sine 45. So what would be sine 45? So opposite by hypotenuse, that is 1 upon root 2. Similarly, for example, let's take cos 60. What is cos adjacent by hypotenuse? That would be 1 by root 3. So what is cos 60? Opposite by hypotenuse, I'm so sorry, 1 upon 2. So what is cos 60? 1 by 2. So this is how we can derive the entire this table. And when we see for this 0 and 90 degree, there's this trick. So just write sine cos 0, 90, 0, 1, 1, 0, 0, 1, 1, 0. So what is tan? Tan is sine by cos. So that would be 0 by 1, which is 0. And what would be tan 91 by 0, which is not defined. So similarly, we can derive the complete table. So for these 30, 45, and 60, we have these two triangles, and for 0 and 90, we have 0, 1, 1, 0, 0, 1, 1, 0. Now let us look at a real life application of trigonometry. You guys were thinking there is no real life application of whatever I'm teaching, the triangles and the table and everything. So for example, let's put yourself as an urban planner and you want to install street lights in your city. And the height of a pole is 25 feet. This is a street light with height of 25 feet and the angle it throws light is 60 degrees. So here the light would be in the night and we need to calculate the ideal distance between two street lights. So we need to calculate this distance so that we can put one more pole over here and the light would be thrown like this. So how to calculate this? So as we know, this would be 30 degree as sum of angles in a triangle is 180 degree, and this is now a 30, 60, 90 triangle. So we can see tan 30 is TOA, opposite by adjacent. So tan 30 is 1 upon root 3 is equal to 25 upon x. It is basic mathematics. So x would come up to 43.3 feet. So we need to install a pole 43.3 feet from the previous pole. So this is one of many real life applications of trigonometry. Yes, so that's it for my. So thank you for your time and consideration. I deliberately made this video very short so that you could understand the basics of trigonometry in a short time and you could keep the concepts with you until the end of your life. Because the remember the mantra so ka toa, and this would help you to not forget trigonometry even if you wake up in your dreams and someone asks you what is sine. So opposite by hypotenuse. So similarly, you can like do all the basics of trigonometry, and I believe this is good for a foundation class. And if you want something else, you can contact me, and I'm happy to oblige to your instructions. Thank you.